Alright, FST, still with me? Alright, here we go. Just something from Chapter 8, which I hadn't got to in class either, I don't think. Does the following sequence converge? If so, find the limit of its nth term as n gets closer to infinity. Okay. Does this thing converge? Well, you had a nice rule about whether or not it converges if it's geometric. If it's geometric, then you can look at what that constant ratio is, and if the constant ratio is absolute values, less than 1, if it's between -1 and +1, then great, it converges. This one is not geometric. There is no such thing as a constant ratio. You just have to look at the formula and go, okay, what happens as n gets really large? Well, this starts to get to be like a zillion over a zillion plus 1. To me, that sounds like that's going to get really close to 1. I mean, the top and the bottom of this fraction are going to start to look really close together as we get huge values for n. The 1 isn't going to really matter when you have a million over a million and 1. That's really close to 1, although it's always going to be slightly less. The trick they had in the book was divide the numerator and the denominator by n, which, wait a minute, I'm getting ahead of myself. Divide the numerator and the denominator by n, then you're going to get 1 over 1 plus, there we go, 1 over n. And this thing starts to turn into 0, so who cares? So the whole thing starts to turn into 1 over 1, which means the whole limit turns out to be 1. So I would say yes, converges, and the limit seems to be 1. Okay, season tickets to the Northwest Symphony Orchestra have increased $4.50 a year since the orchestra came into existence 18 years ago. During this first year, individual season tickets were $32. Wow, that's cheap. What will season tickets cost for the 18th year? Okay, so the sequence here goes 32 the first year, then it's going to go plus, just to give you an idea what this sort of feels like. 36.50, then it's going to be add another 4.50, it's 41, etc. And we're looking at what is it going to be the 18th year. Now this is an arithmetic sequence. It's just going up by the same constant difference each year. We're not multiplying anything, we're simply adding. So we're looking here for the 18th member of that list. Counting this as year 1, we want year 18. So that is always found by taking the first one plus n minus 1, can I do that? Is that going to bother you? Times 4.5. And if you do that, you get 108.50. Am I going to fit this in the screen? I think I am. Okay, good. Alright, so Aunt Myra has purchased a season ticket each year. How much has she spent? Alright, so we're actually going to take this, plus this, plus this, plus this, plus all of these, and include that one, and add up all 18 of these. So what we're looking for here is the sum of an arithmetic series. Which you have a formula for. It is n over 2, and here it's nice because we actually know what n is, times, notice I said I'm going to make these, I'm picking the test-like ones. Okay, 2 times 32, 2 times a sub 1 plus n minus 1 times d. Okay, and you do that, and you get $1,264.50. Alright, great. Show your work. You remember how all that goes. Okay, so that was it for sort of marching through all the chapters, except for Chapter 10. I don't feel like I really need to do a lot of that on video, because there's a bunch of that on video if you just scroll back a few videos, because we just did that chapter. Yes, there is Chapter 10 on the final. Okay, but here's something from a random chapter that I'm not going to mention what chapter it is, because that's what the final is going to feel like. You just have these questions that are scattered all over the test, and you got to go, okay, why, where does that come from? How do I approach this problem? All right, here's a right triangle. I know all 3 sides. Find the tangent of f. Exactly. Okay. Compared to f, we're supposed to find tangent, which would be the opposite side over the adjacent side, which, looking at f here, opposite is 5, adjacent is 8. That's not so bad. Tangent is opposite over adjacent. Sine of x is, now compared to x, we're looking at opposite, SOHCAHTOA, opposite over hypotenuse. But, 8 over square root of 89, oh, check it out. If you don't believe me that that's sort of rude to say 8, I shouldn't say rude, really. It's like misspelled to say 8 divided by the square root of 89. Whoops. 89. I said 89. Speaking of rude, you shouldn't do that. You should say 8 times the square root of 89 over 89. Isn't that cool? All right. So this is actually better to say it this way. Okay, and the cosine of f. Back to this one. Adjacent is 8, and hypotenuse is square root of 89. So, well, guess what? Of course, the cosine of f is the same as the sine of x. Remember that little identity. Another way that they, I mean, the reason they call it cosine is because it's the complement's sign. It's the sign of the complement. X and F are complementary. Find the measure of angle X to the nearest degree. Well, we went to all this trouble to figure this out. Well, I have this sticking in my calculator. I could just find the inverse sine of that. Although, if you don't like to type all those numbers, you could look at X and go, you know what, tangent is easier to type. Opposite and adjacent is 8/5. I can go, what's the inverse tangent of 8/5? We want degrees. Am I in degrees on this thing? No, but I can change that. This is how easy it is to change for those of you getting this calculator someday. Yeah, fine, I'll do that. Inverse tangent of, and yes, you actually click on it with a little mousy thing on this calculator. Inverse tangent of 8/5. 8/5 would be opposite over adjacent, correct? Oh gosh, did you see the answer it gave me? It gave me an exact value. This looks like radians. Am I in radians? No, I'm in degrees. And it still gave me that. Oh my gosh. Oh, that's what this 90 is here for. Okay, let's not do that. Let's just do approximation. Wow, that's just impressive though, isn't it? That's the exact value of, you know, the inverse tangent of 8/5 in degrees. If you do this thing with degrees, you get that. All right, it's actually really close to 58. So why didn't they say that? To the nearest degree, that's really close anyway, to 58. Okay, here's some other random ones from around the semester. A test includes 7 multiple choice questions with 4 choices, 6 true false, then 7 now with 3 choices. How many different answer sheets are possible? Well, you can think of it this way. How many ways are there to answer the first question? It's a multiple choice question with 4 choices, so there's 4 ways to answer that question. Second question, 4 ways, and there's a bunch of these. There's 7 of these, and then I have 6 true false. There's 2 ways to answer the first one, 2 ways to answer the second one, blah, blah, blah. And there's 6 of those. And then I have 7 of the following, which have 3 choices each. So it's like I have to take 4 times 4 times 4 times 4 times 2 times 2 times 2 times 3 times 3 times 3. So I have 4 times itself 7 times. We call that 4 to the 7th. Most people got these mixed up. They call this 7 to the 4th. It's 2 times itself 6 times, and then 3 times itself 7 times. And that's all there is to do. 4 to the 7th. What? I said 4 to the 7th. Times, am I out of the exponent? I don't think I am. There we go. Times 2 to the 6th. No, to the 6th. See, there's a little bit of a problem. When you have the actual calculator, it's easier to push the button. Times 3 to the 7th. And it's huge. 229, 323. I'm going to look back at that. 229, 323. Where is it? Here it is. 5712. Yes, it's that many. There's a lot of ways to answer that. It's over 2 billion. So if 2 people hand in the same sheets, you could suspect cheating. Okay. Susan wants to buy 3 different soft drinks, 4 types of chips, and 8 kinds of dip. Oh my gosh. Okay, 3, 4, 8. The store sells 16 kinds of soft drinks. Okay, whoa. So of the 16, she wants to buy 3. She's choosing 3 of the 16. Does it matter what order they're in within that? The 3 out of the 16? Probably not. So I think I want to use that way to count those up. And, which is times, which is the most important thing people forgot. 4 of the 10 types of chips. 4 of the 10 types of chips. And 8 kinds of dip. Who needs 8 kinds of dip? She's only got 3 kinds of soft drinks. How, okay, fine. How picky of people does she have about dip? All right. There's only 9 different types. So there's really only 9 ways to do this because there's only one you have to not pick. All right, 16C3 times 10C4 times 8C9 times. I'm going to figure out each one of those separately. This looks a little bit different on this calculator. I had to figure out how to do it. It's 1820. Oh, did I do 16C4? I think I did. All right, 16C3. Enter. Can I go back and delete this? Yeah, 16C3. Do it that way. It's 560. 560 ways to choose the drinks. All right, 10C4. So on the new calculator, it goes like this. You just say 10 NCR4. But here you got to go menu, probability, combinations. What was it, 10-4? 10-4, good buddy. All right, 210. And 8C9. Does it bother you? I'm using the wrong calculator. You know what? 8C9 I know is 9, but if you really cared to see that. Oh, it's 9C8. 8C9 doesn't make sense. That's 9, yeah. But realizing that not choosing 9 things out of 8 doesn't make sense. I was thinking 8 of the 9. Well, 8 of the 9s are like that. All right, so 560 times 210 times 9. 560 times 210 times 9. Another huge number, probably. 1 million. Or so. Okay, yep. Seems like a lot, but it actually is true. Oh, and that's it. So I'm at the end of the random ones I also picked. Here's some ideas for what to put on the formula sheet. Remember, you get 2 sides of A4. I think this is already loaded up on Blackboard as a static sort of document. And I remember I gave you, there's a sheet I passed out that has the top half of one side has the unit circle. If you wanted to fill that in the way I had it, you don't have to. You can start with your own. Remember, this is due Tuesday at 8 a.m. Okay. Then I know that's at least 2 days before your final. Okay. So that's it. I'll wait for more emails and or YouTube video comments and or views to my YouTube videos to see if I need to be making some more of these. Good luck.